Where I grew up in the mountains outside of Portland, Oregon, I could look up in the sky and see thousands and thousands of stars in the night sky. And I would wonder, where did all this come from? I find it amazing that I can rewind the clock and go back and look at what existed in the universe before any of those stars were even created. And we can recreate the conditions of the early universe, and we can study the force that holds together that matter, as well as all of the matter that exists in the visible universe today. I'm Paul Sorensen. We're in the main control room of the Relativistic Heavy Ion Collider, an atom smasher at Brookhaven National Lab. From this room, we steer ions around a 2.5-mile circular track and smash them together at nearly the speed of light. When we collide the ions, it creates a fireball that only exists for 1/billionth of 1/billionth of 1/millionth of a second. A very, very brief amount of time. And the fireball is only 1/billionth of 1/millionth of a meter across. So this is a very short-lived and a very small speck of matter. But with the detectors that we have, we can look at all of the remnants that come flying out from those collisions, and we can trace them back, and then look at the patterns of how they come out to try to understand what the matter was like that created all of them. One of the most amazing things that we've discovered at RHIC is that this matter that we recreate is very much like a liquid as opposed to a gas, which many people thought it would behave like before. So it's amazing that this matter, which is 250,000 times hotter than the center of the sun, actually behaves a lot like a liquid. This is what the early universe was behaving like, so we're really peering back and looking at that. This fundamental research brings together some of the smartest people in the world to try to solve some very difficult technological problems. How do you accelerate these gold nuclei, for example, up to such high energies? How do you detect what's coming out from all of the collisions? How do you analyze all the data that's coming out? This leads to advances in superconducting magnets, it leads to advances in detector technology, and it leads to advances in computing. This is also where the next generation of scientists will be trained. And who knows what they're going to go off and do and discover with the knowledge that they've gained at RHIC.